Hello, this is Andrew. Okay, I did some effort to redo the Project 1 IP addressing plan. My orders are that, nobody gets through this course unless they understand this material. So my effort is I go back and try to make it more clear, more easy to understand, and more easy to do such that you still learn the material. So I hope that we see that happening here. Okay. So basically, we have the problem description. If you looked under the assignments section, you'll see this. This is the same problem description. Design an IP addressing plan for a network design provided by the instructor. So that's what this is. It's the network that I'm designed. Okay. The plan will, as a minimum, include fixed addresses for routers and servers, address pools for DHCP, and a list of ports which will need to be open on each of the services. For each open port, the plan should list the related service. The plan will include both IPv4 and IPv6 addresses. The plan must include static routing, providing connections from all computers to the internet. Students must cite sources used to determine port numbers and other references. Okay, so some things. This is, again, an introduction. It's a basic class, and there's some things we just won't be addressing or including in these networks, and that's description of ARP, MAC address functions, or layer 2 switches, layer 3 switching, dynamic routing, NAT and PAT and VLANs. These are all pretty basic concepts as well, but they won't be included in this project because this was the description I'm given to. So what we will include is static routing IPv4, IPv6, subnetting IPv4 and IPv6, ports, basic network topology, and some server discussion. Okay, so let's discuss the procedures quickly. Alright, watch the provided 6 videos in the announcement section of the course. Watch this video, which is entitled Assignment Project 1. It'll be in the announcement section of the course. This document alone is not fully intended to describe the whole assignment. This video is meant to go with it. Okay, so you're going to do a Word document write-up that includes the following sections. An introduction, which just describes the problem. IPv4 addressing, calculations, tables, topology with a dynamic range. IPv4 static routes. DHCP pool commands using proper Cisco syntax. And then after that, you'll repeat the whole thing using IPv6. So you'll do an IPv6 addressing, calculations, tables, topology, and dynamic range. IPv6 static routes, DHCP pool commands. And then at the very end, you'll do an open port list and explanation. So this is what ports are you leaving open? Why are you leaving them open? Things of that nature. All right, then you're going to do a conclusion. So let's look in a little more detail. Your IPv4 addressing plan. Use VLSM, and we've discussed that, and subnet this network address, 192.168.1.0/24, network into 7 subnets according to the topology on the following slide. That's slide number 5. You must add 100% room for growth to the server areas because we may use backup servers, we may add new servers. You've got to have room on your IP addressing scheme for more servers. 20% room for growth to your clients. That's also to allow for bring your own devices such as tablets, iPhones, things of that nature. They all need an IP address, so that you have to have IP addresses available. And what you got to understand is the reason for the variable length subnet masking is such that you don't waste IP addresses. You want to use as many as you need, but you don't want to reserve more than you'll ever need. So you must show all your work how you calculated the proper subnets, okay? No credit will be awarded if you do not show your subnet calculations. So create a table as in the Project 1/3 video. The table should include the subnet name, the needed size, the block size, the network address, the CIDR notation, the subnet mask, the IP range, and the broadcast address. So once you've done all that, then you should have your calculations of how you got all those answers. Check this with the VLSM calculator. Here's the address for that. All right, put your calculated table next to the VLSM calculator table in your write-up. There should be no error here, okay? Do an alt print screen of the topology slide number 7 and paste it into Paint, and then enter your IP range on the red line. So the values you got that you entered on this table, you want to enter them on the red line in this slide. And then once you've entered those values, copy this form from Paint to your Word document. Okay, IPv4 DHCP pool and static routes on each router. So on each router, enter the correct DHCP command using proper Cisco syntax. Enter the range for the values that you assign to the topology table. So basically all that's saying is you already got the range up here. You calculated the range for each subnet. So wherever you want to put it on a Cisco router, in real life we would use a DHCP server, but in this project you can use the closest Cisco router. And on that router, use the Cisco commands for a DHCP pool. Just put the command on and for the exact values you calculated up here. All right, make a table for each router. List the router name, number of static routes, each static route on that route. Now, if you use summarization, like we did in that video, then be sure to describe clearly what you're doing. I recommend summarization is not really a requirement of this project, so I recommend maybe don't do it, but if you feel comfortable with it, by all means. Okay. If not, then just describe each static route that's required. Okay, ports. So what you're going to do is then after you get to here, you just repeat steps 4 and 5 for IPv6. So you go through all this. You're not going to really get a VLSM calculator, but watch the IPv6 video I showed you, and I really give you the subnetted IPv6 addresses in there that you can use. So just use those. Then the same thing here, do an IPv6 DHCP pool and static routes on each router. All right, then after all that, then you want to do the ports. Determine which ports you will leave open, why, and the number of the port. Include this in your write-up. Then write a conclusion. What did you learn? A discussion of what each server is, what the DMZ is, etc. You know, just include a lot of stuff in the discussion. Okay, so here's the actual topology that we're going to be looking at. Over here, this is going off to the internet. So we're not going to worry about this interface because what's going to happen is the service provider is going to issue us a IP address via DHCP. So we're not going to worry about that, okay? But so here we have basically 3 routers and 3 different buildings, and all of this is in Seattle, okay? So router 1 is in this building, and then off of this interface we have an area called its DMZ, okay? And in that DMZ we have various servers, an Apache web server, DNS external server, and an FTP public server. Okay, so then we're going to run over to building 2, and in building 2 we've got a network coming off of this router going into these 2 switches, and there's 100 PCs between these 2 switches. Now remember, a network is an interface of a router, so the switches are not different networks, at least not in this course, okay? What we're looking at is layer 2 switches here with no VLANs. So and as far as this course is concerned, these switches are all part of the same network. So these here are on the same network and these are on the same network. But this is a different network, okay? And there's 30 PCs on this network. So maybe we'd look at this as like building 2. This is floor 2, floor 5, floor 8, switch 1, 2, and 3. On switch 2 and 3, we have maybe engineers and salespeople, things of that nature. Down on this floor, maybe we have accounting. We want them to be separate to kind of keep the booking separate from bookkeeping, separate from these guys. Then over here on building 3, again, we have 2 networks on here, right? This is our server room. These are our internal servers. These are the servers in the DMZ. All right, so here we have a DNS server. Here we have a DHCP server. Here we have Active Directory Exchange. And here we have MySQL. Okay, so when I say add 100% for the server area, so that means this network right now at this time has 4. So you have to have 4 addresses for that. To add 100%, you have to have 8 addresses. So this network needs 8 addresses. Okay, now this network is a client network, so you only need to add 20%. So 20% added to here is 4. So you need 24 IP addresses on this one. Okay, so you have to pick the correct block sizes such that these subnets fit into that block size when you subnet the 192.168.0 network. Okay, so let's just make sure this is clear. How many networks are there? Not excluding this one, because we're not dealing with that at the moment. So you have one here that goes to the DMZ. Each branch of the router is a network. 2, 3, 4. 4 includes all of this here. Okay. 5, that includes all of this. 6, that includes all of that. And 7 includes all the servers. Okay, so this is the slide we said once you get your IP address ranges, include them up here. So this will be network 1. You're going to include, I'm not telling you what it is, but let's just say it's 192.168.1.1 to 192.168.31. 192.168.1.31, and then all of that you can do /20, whatever it is, whatever /32 is. Okay, so you can finish that. I hope that makes sense. All right, so enter your range of your IP addresses that you calculated from the tables on the previous page and put them in here. So then what you want to do is take a screenshot of this page, put it in Paint, fill in your ranges, and then highlight it, cut it, and paste it into your Word document. Okay, so let's just quickly take a look at the routers only. So we pulled the routers out of, if you go back here, we pulled these routers, right, out, and we're just looking at the routers. Okay, so actually, if I stretch this R3 up here, let's blow it up. And if I stretch this R3 up here, this is really, notice this is the same topology as in the connected and static routes video. So if I pulled this R3 up here, then R1 equals Jane. R3 equals Jake. And R2 equals Roxy. So it's the same. So really, if you watch that video, this is a little different because, there's only one network going off of it where he had 3, and there's only 2 here where he had 3, and there's only 2 here where he had 3. But basically, it's very similar to that one I gave you a video of. So that's really telling you how to do the static routes. So basically, anything here needs to reach anything over here. Anything here needs to reach anything over here, and anything here needs to reach anything over here. Everybody has to reach everybody. That's what's called full connectivity. And that was in the problem description. So the static routes are important. So what you got to do is R1, how many static routes do you need? Okay, determine how many you need. How many you need for R2 and how many you need for R3. So write down how many 5, 4, whatever it is that you need, such that you're getting full connectivity. And then after that, write each static route in the correct Cisco syntax. And also don't forget to write the DHCP pool on here as well. Just you can just Google that command, and basically what'll happen is this router can use that pool and issue out the IP addresses to all the computers here and here. Now, right here on these interfaces, you can't. I'm pretty sure you're going to have to assign these. So what you got to do is look up the command of how to assign an IP address to an interface. Use the interface here, F1 and FO, and assign static IP addresses to these and static IP addresses to these. So that's 4 static IP addresses you'll have to assign. Don't worry about these. And then here you'll have to put commands to DHCP command that uses the pool to assign these servers, and this one you'll have to assign these servers, and this one you'll have to assign the clients and clients and clients. Okay, so once you get done with all that, just do it again for IPv6 as we discussed. So, if you watch the IPv6 video, I pretty much gave you the commands that you're going to use and the addresses that you're going to use. So that should be pretty clear at this point. Let me know if you have any questions. And this will be assigned actually Monday the 13th, and it'll be due the following Sunday. So good luck, and thanks a lot.